Welcome to the future.
Welcome, my name is Grim from Seed to Shelf, and today we are going to be teaching you how to build an extraction laboratory. Super excited to get into this with you guys, get these questions all the time, so we are going to break them down today. So in order to build an extraction laboratory, there's some things that we need to figure out before we can even start planning out our building phase. Number one is, what are we making? That's going to explain to us what kind of equipment we need to source, how we need to source it, and what we're looking for. Is there a particular product that we're looking for? Are these going to be dabbables, vapables, CBD crude oil, CBD isolate? What exactly do we have a market for, and how can we model our business model after that? Number two that we need to figure out is throughput requirements. How much do we need to produce to fulfill our bottom line? And I understand that scaling may happen in the future, but bare minimum, when we start out, how much do we need to make sure that we can meet our deadlines or our throughput projections? Number three, most important one, what is our budget? Do we want the best and the safest that money can buy? Which, as a consultant, I would tell you that's the direction you should go. Or are we okay to cut corners for future investment? How much do we have to spend on what we are trying to produce? And these three things, the what are we making, the throughput requirements, and the what is our budget, is going to determine all cohesively together what exactly we can produce. The fourth and final step that we need to figure out is who is going to train us, or do we have a centralized knowledge base on hand that is going to be teaching us how to do our processes, our SOP, our post-production, and training all of our employees? Do we trust the manufacturer? A lot of the times the manufacturer is going to come and they're going to do a dry run for all of your equipment. Or maybe they'll give you tips and tricks on how they feel you should run their equipment. Are we okay to trust their word that they know how to make what we're trying to make? Or do we need a more specialized knowledge base? Do we already have that specialized knowledge base? Maybe as we're building our projections, maybe as we're building our business model, we have a young aspiring student that just came out of college with a degree in chemistry. Maybe that's okay. Maybe we have a long time industry entrepreneur or industry technician that has been here for a decade or so, and we have him or her available to us. That might be okay. Should we hire a consultant? All of these are going to go into who is going to train us. I would personally recommend that even if you do have a centralized knowledge base, that you do not rely on the expertise of the equipment manufacturers. While they may be chemical engineers, you might find that they're not necessarily organic chemists. And there are some nuances that come into play whenever you begin to build your extraction laboratory that maybe aren't identified just from the source of equipment manufacturers. Also, the same thing with your knowledge base. I would advise that you hire some sort of consultant that can come in and get a second pair of eyes on things. Maybe help and work with your centralized knowledge base, if you do have one, to identify any potential bottlenecks or hangups that might already be in your process. So, very first, this is going to be a cohesive business plan. That's the first thing that we need to figure out before we even begin to start doing sales projections and all of those other things. We need to make sure before we buy equipment, before we get all of our licenses, we have a business model that we can go for. All right. Now, some common products that are made inside of an extraction laboratory include pretty much 4 target areas. These can be dabbables, vapables, edibles, and topicals. Now, there are a bunch of different products in between each and every one of these target areas, but these are pretty much going to encompass the majority of products on the market: dabbables, vapables, edibles, and topicals. So, in order to do all of these things, there are different ways to build different extraction laboratories based on what product are number one that we were just talking about. What are we making? Once we figure that out, then there might be a different laboratory and a different setup for each specific one. So for the intents and purposes and trying to give you the best value that I can in this video, we're going to make some assumptions based on current market research. Number one, Let's say that we want to make dabbables, but we also want to be able to make vape pens. With dabbables and vape pens, we're going to target and corner much of the recreational market. And since everything is kind of leaning towards the recreational side, and that's where the majority of your sales are going to come from, let's go ahead and assume that this is the laboratory that we want to build. It's more lucrative. Let's also make an assumption that we have 750 square feet bare minimum of space that we can dedicate to just manufacturing or extraction and post-production. That means that we might also need additional square footage if we're going to be something like vertically integrated and we're going to have a dispensary and a grow operation all in the same situation. So packaging, all of these distributions will also need additional square footage of space. For the purposes of this video, we're going to talk about how to build an extraction lab. So for that, we're going to assume we have 750 square feet. Now, let's also make a very serious assumption that we live in a state where this is legal. Now, we are contacted often, especially as these things are branching out all over the world, about people that kind of live in a legal gray area. So I cannot really help you here if you're trying to build this type of laboratory. I would definitely make sure that you're complying with all state and local laws, regulations, to make sure that whatever you do have going, the number one thing in your business proposition is risk management. The more risk that you can manage is the more potential profit that you're going to have in the future. One of the major risk factors would be that if you're not in a place where it's legal and the feds kick in your door, you have a big problem here. So let's make the assumption that we do live in a state where it is legal to manufacture recreational products. Let's also make some assumptions that we either have access to or are going to be supplying our own biomass. We are going to need some sort of feedstock, as an extraction laboratory is solely based on the extraction and post-production of some sort of feedstock. So we're going to assume that we either know somebody or have contracted or are growing ourselves some sort of biomass, in this case, cannabis. Let's also make an assumption that we aren't cheap, but we don't want to overpay for every little shiny new piece of technology on the market. We want to be clean, safe, legal, and effective. So after we've made these assumptions, we have effectively targeted our 4 problems that we had when building our business proposition. So to review, we want dabbables, and we also want to be able to make vapables. We have approximately 750 square feet of space. We live in a state where it is completely legal and we're complying with the law. We have access to or are supplying our own biomass. And although our budget might be expansive, it is not overly exuberant to where we just want to buy every little shiny new thing just because it's the shiny new thing. But we do want to be clean, we want to be legal, we want to be safe, and we want to be effective. I would always consult you that no matter what, even if these are not current market laws right now, because they're not, that you would always operate due to a CGMP and pharmaceutical nature. Some of our clients even like to take it above and beyond and adhere to ISO 9000, which is a standard in the pharmaceutical industry. I say more power to you, because eventually you are going to have, especially when we're looking at becoming legal not only on a state level but also a nationwide level, you're going to have federal regulators come in, probably the FDA, and they're going to want to regulate. Well, what can we do if we kind of can project that they're going to regulate anyway? Well, we can look at other areas in the market that those regulations exist. So for this case, the Food and Drug Administration. And if we adhere to CGMP environments, then we can guarantee ourselves almost that if the regulations do come, our laboratory will not only be just right now in the current market, almost like the Wild West, but will be able to be sustainable into the future for long-time growth, no matter what regulations come our way. Okay, so now that we've got all of our business models set up, we know exactly what we want to make, and we understand the process, how it's going to come through. Now we need to hit the 7 target areas of our extraction and post-production process for the products that we already predetermined we wanted to make. In this case, we're going to be doing vapables and dabbables. Area number 1 is extraction. Area number 2, oven production. Area number 3 is winterization. Area number 4 is decarboxylation. Area number 5 is going to be distillation. And area number 6, because we also want to make a vapable product, then we are going to need to have a filling and terpene station. There are many people that like to fill their carts by hands, the purists, if you will, and I do understand that. It is just very difficult to get that throughput to scale without hiring extensive employees. So we're going to make sure that we have a piece of infrastructure in line for that. And the number 7, which is the most important, but isn't really related to production as a whole, is safety. You've got to understand that a lot of the materials, solvents, gases, any other things that you're going to be using, catalysts, all of these things are going to be coming into your extraction and post-production process. That means that at the end of the day, if you've got a perfect business model and you spend the whole time developing it and you've done a great job and you can make all of the money in the world, but one of your employees and or yourself is at risk, there's no amount of money that we would be willing to make at the risk of our own safety or the safety of others around us. So we want to make sure that we have invested or at least set aside significant capital and investment to be sure that we cover that area of safety and that we're operating safely with all of these potentially dangerous or hazardous materials. Target area number 1 is going to be extraction. So because we already know what product that we're trying to make, the dabbables and the vapables, what I like and truly believe there's no replacement for is an LPG closed loop system. So for this, I like the closed loop extraction systems, and I like the ones that are customizable because a lot of the new shiny bells and whistles that have all the automated controls and everything like that, through years of experience, you will find the ability to manipulate your piece of equipment and customize it to fit your needs and your throughput will go a long way for actually increasing not only your stability and security and how you feel about your working environment and the control that you have over your systems, but also the color and the clarity, the purity, and all of those other target areas that we definitely want to meet and or exceed if this is the product that we are trying to make. Now, some people will kind of advocate for the CO2 extraction systems. And for these particular products that we're going to be making, is CO2 an ethical solution? Yes, it absolutely is. I personally do not advocate for the use of CO2 machinery. Number 1, because it's very, very, very slow. It's very slow, especially with comparable rates to how you can set up a closed loop LPG system. Number 2 is the infrastructure is very, very expensive. For about the exact same throughput that you can do for $20,000 or $30,000 inside of a closed loop extraction system, you're going to be well into the $750,000 to $1 million area for a CO2 system. Now, I understand that using supercritical CO2, one may feel that this is a safer method of making it. And yes, as it pertains to CO2 versus butane or propane, you are absolutely correct. However, if trained how to do things safely and effectively, you will find that the risk factor is very much the same. The third reason that I don't really like to use CO2 equipment is because CO2 is going to pull all of the fats, lipids, and nucleopeptides out of that plant. That means that not only are we losing production on crawling through the CO2 extraction phase, but now we're going to have to ramp up or beef up our winterization filtration post-production procedure to make sure that we can effectively isolate and neutralize all of those fats, lipids, and nucleopeptides, sugars, waxes. All of these things are going to create a problem for us in the long run if this is the way that we're trying to make a purified product. So for the LPG systems, I love them. You can use them for any type of shatter, dabs, wax, crumble, butter, diamonds, just about any oven production artisan product that you can think of. But also it leaves you the option to reintroduce a solvent, which we'll go over in just a minute. And then you can also make your vapable products, all with consistent throughput and the ability to handle and customize your machine. So for us, that's what we feel is the best solution in this case. Plus the throughput is, the footprint is small and minimal, which means that we'll be able to adequately delegate more of our square footage, since we only have 750 square feet, to the rest of the post-production process, while still maintaining a large workhorse in the extraction area. Target area number 2 is going to be our oven production. Now for ovens, I really like Across International's ovens. And the reason that I like those ovens, a lot of people say that all ovens are the same. But there's a key piece when purchasing a vacuum ovens, because you can find them from a range all the way down from $1,000 all the way up to $25,000 for the same cubic feet inside of that oven, and they technically do the same thing. However, there's one critical piece of the oven's infrastructure that will drive you nuts, especially if you're trying to adhere to a consistent parameter or procedure. And that's going to be number 1, the vacuum seal around that door. So even if you get a brand new oven, for example, like a Cascade oven that's got all the new digital technology, it's got an LCD screen, it looks fantastic, it's a beautiful piece of equipment, you will find that that Viton gasket is not seated as properly, right? And that's nothing against any of the equipment manufacturers that I may be speaking about. Our job here is to make sure that you, the people that are watching this, would get a professional opinion on what we would use in our own laboratories. We would not be trying to sell you or teach you something that we ourselves would not use as professionals in this industry. So these are some problems that I find that we can have. Yes, maybe I am able to purchase a slightly cheaper oven for $3,000 or $4,000 less investment in my beginning. However, if I'm always having a problem maintaining a vacuum, or my temperature swings are wild every time I release the vacuum to atmospheric pressure to remove whatever I am making inside of my oven, then I find that I really have more of a problem than I did going in. So, and I know I said only one, but there's 2 things. The other thing is the way the oven heats up. Are there little filaments? Is every single shelf heated, or is it a continuous heat throughout? And also, how well does that oven contain its heat even if I open the door? So for instance, when making butane BHO or shatter, I'm going to have to remove those slabs from the oven to do a flip and then a re-purge. If while I'm opening the oven and pulling my slabs out to be able to do a flip, I drop 10 degrees in temperature and then put it back in, and then the heating filaments have to overcompensate for that heat loss, and then they're cooking my slab, what I'm going to notice is that I'm going to lose stability inside of my shatter, which is very important. That's why it's called shatter. You should be able to break it off. So if I fluctuate a lot with my heat and I'm not able to maintain consistent parameters all the way through the process that I need to make sure that I'm adhering to those parameters, then I'm creating a problem for myself. And at some point, the $2,000 or $3,000 that I might have saved in the beginning is not going to be worth it or behoove me in the future. Oven production is very important. So this is another area that you need. Next is winterization. Now this is going to come more into the line when we're talking about making vape pens. Obviously, and there are many people, look guys, there are many people that are saying that if you're doing BHO, shatter, wax, dabs, crumble, something like that, that is going to be a dabbable, smokable product in something like a dab rig, right? That you are going to need to do something like a winterization process, but in the LPG systems, a lot of people are calling that a dewaxer. Now this dewaxer takes up a lot of time, an additional 45 minutes to an hour. So depending on the solvent blend that I'm using in my LPG system and us personally, let's say that we're going to be making crumble, for example. I like to use an 80% propane, I know, call us crazy, and a 20% butane mixture. So I've already decreased my boiling point so far that I'm going to be able to recover rapidly. If I then have to take and go through a dewax membrane or filtration system or just another column that is super chilled, I'm going to lose a lot of throughput there. So what I've found that you can bypass, and we're getting on a tangent here, but we want to give you as much valuable information as possible, is if I bypass that dewax column, and what I do instead is make sure that I'm keeping my solvent cold, my columns cold. I'm freezing the biomass before it goes into the closed loop extraction system. I find that I do not pull as much of the fats and lipids, actually a negligible amount, as it pertains to shatter, wax, and crumble. Now, obviously, when I get into making the vapeable product, I'm going to need to go through a winterization process to remove all of those fats and lipids, because if we cannot get a 90 percentile vape pen on a first pass, not a second or third pass, because throughput and consistency is everything, that all equals money at the back end of our production pipeline. I need to make sure that when I'm going into my short path distillation system or my wiped film distillation system, that I'm able to do a first pass at a 90 percentile total active cannabinoids. That means that on the beginning end, I need to take out as much of the impurities as I can as possible. That way I can make sure that I hit those projected numbers moving into the distillation phase. That's why winterization is so important. So there's 3 methods that you can use for winterization. Number 1 is you can use the cryo fridge or in the mason jar tech. So this is a simple way of introducing 3-to-1 solvent to oil ratio, freezing it, and then filtering it every 24 hours. This works great. It is even able to go up to about medium scale, and you can do it without too much significant investment in the winterization filtration stage. Can you skip it? No, you cannot skip it. This is the number 1 rookie mistake, especially you find this more in the CBD crude oil area or anybody that's using ethanol. But I think that there was a misconception, and it was approximately 4 or 5 years ago that this misconception started circulating, that if you get cold enough that you're not going to have any fats and lipids transfer over. And while I know that sounds counterintuitive because we just told you that using propane to make shatter, that you would have a negligible amount. But I made sure that we told you as it pertains to shatter. When you're getting into distillate, you are going to have those. When you get up to scale and you start skipping that winterization filtration process, you'll find that a lot of your pumps get clogged and you'll find that you're having purity problems. You run everything through and your first pass is getting a 65 to a 70 percentile range in the total active cannabinoids as it pertains to distillation. For us personally here at Seed to Shelf, this is unacceptable because that means that we're going to need to do another run. There's going to be more loss, more employees needs to be paid, and our throughput is going to be cut almost in half. So we need to do the winterization. Also, it's duly noted that yes, if essentially, theoretically, and scientifically, if you took something down to negative 60 degrees Celsius and proceeded through your extraction phase, it would be so cold that very little of the fats and lipids would come out. And at this point, you probably could skip winterization. The problem is that all of your solvents are going to have a saturation point. That means the colder that you get your solvent that's being used, the less cannabinoids it's going to pick up. So if you manage to get a 0 winterization or filtration, but you're averaging a poor performance of 6 to 8% yield, even though your solvent is cold, this is not good for us, right? So about negative 30 is as cold as you want to go. That's at the point where all of your solvents are still going to have maximum retention for all of your total active cannabinoids, but also they're going to pick up fewer of those fats and lipids. But that unfortunately means, or fortunately, depending on how you look at the table, that means that you are going to have to do winterization. So cryo fridge mason jar tech is a very advocable method. Number 2 is your lenticular filter tech. Now this is going to come into when you're moving into a larger scale. That means that, you know, you're way past, maybe you have 3 or 4 extraction production machines. You've got, 24 to 25 ovens that are hanging out. You've got 3 or 4 distillation machines, and you need to slam oil through a winterization procedure. One of the things that you can do is use the lenticular filter along with a pump. You reintroduce your oil into a bunch of solvent the exact same way, 3-to-1, super chill it down, probably something with a nitrogen holding tank, subcritical everything, and then send it through these lenticular filters. I really like these lenticular filters. They're customizable. You can even throw some carbon filters in there, but they do deteriorate over time. So you'll be able to get about 30 to 90 days, depending on your throughput, out of each filter before you need to replace that. So just keep that in mind. It is a great solution, especially if you're moving at scale. Everything's at 316 stainless steel. It'll all equal CGMP at the end of the day. So it makes a really great solution. Now, the other thing that you can do, especially if you're moving into scale or even at subscale, but have a plan to scale in the future, is some nanomembrane tech. And basically what this is it's used in the saltwater industry. It's been used in the saltwater industry for decades, and it has a nanomembrane that is not going to allow the particle size of those fats and lipids to transfer through to the rest of the process, effectively capturing those. So those are three methods that you can use for winterization. Each one is a good method. Depending on kind of what you've got going on in your laboratory, there might be different solutions for you, and they're all going to vary in price. The cryo fridge and the mason jar tech, you can get done with basically what you have around the laboratory already, maybe $1,500 max. Your lenticular filter tech is going to cost you $2,500 to $3,000 up front, $2,500 to $3,000 up front, but you're also going to need to replace those filters often, and those filters are about $800 a pop, so there's something to think about too. Your nanomembrane technology is going to be the most significant investment, however, probably at about $125,000. However, it is a good solution as you won't have to replace things as often, and you won't have to use a bunch of energy, especially if you're more on the green production side, trying to conserve energy, both employee labor and electricity and all those other things. Nitrogen, for example, if you were using the lenticular filter tech, this will kind of combat those areas. So all three are good solutions depending on kind of what you want to choose. My favorite, if I'm using a small solution, is I just use the cryo fridge tech. It looks a little bit archaic and outdated as far as it relates to the rest of the industry and everything with all of its bells and whistles, but hey, it works perfectly. It works perfectly. It's an effective solution to the problem that we have, and we can do it all day. When I'm using huge scale ethanol systems, I'll always go with the lenticular filter tech or the nanomembrane filtration. So just depends on our investment up front. The next target area that we're going to talk about is decarboxylation. Now, I want to dispel another misconception, if you will, that has been circulating over the industry. And if we could figure out how these things begin circulating, then we'd probably make a whole ton of money because we would know the problem before it even showed its face. However, there was another misconception that people think that you can take your oil and decarboxylate inside of your wiped film evaporator or your short path evaporator, which is true. You can. Naturally, as you go to 205 degrees Celsius in your distillation process and your decarboxylation temperature is going to be approximately 140 degrees Celsius, you are going to pass through the decarboxylation phase. However, have you ever had that short path that runs for 6, 7, 10, 12, 14 hours? Maybe you leave it running overnight to come back in the morning and collect your fractions. I know that there are some of you, probably many of you that are watching this video that have had this problem. Rule number 1, break down your winterization and your filtration. Rule number 2, decarboxylate effectively, and I guarantee that you're not going to have that problem. Also, when you begin spitting volatiles or whatever residual solvent is left over, probably ethanol if you're going through distillation, you're not going to have all of those coming out in a large heads fraction. You're not going to be contaminating more of your fractions by making sure that you can dial in exactly where's your main body or your residue if you're using the wipe film, and this is going to enhance your capabilities of being able to get that first pass 90% plus total active cannabinoids. Proper decarboxylation happens at 140 degrees Celsius for 45 minutes. There are some nuances to that. It's a little bit more scientific than that. However, all of our clients, just for the ease of access, until you get some experience under your belt by being able to look at a product that is being decarboxylated and say this is effectively decarboxylated, we tell all of our clients 140 degrees at 45 minutes. This will mean that you have effectively reached a decarboxylation temperature and activated or decarbed all of your active cannabinoids inside of there. Now, something to be said. As long as there's some residual solvent in there, that doesn't mean that you throw it on a hot plate or, your decarb reactor for 45 minutes at 140 degrees Celsius and that's a wrap. Because if there's residual solvents in there, it is never going to allow the temperature to exceed 90 degrees Celsius as long as those residual solvents are in there. Also, when those residual solvents are in there, there's going to be some volatility inside of the oil that you're decarboxylating, which means you're going to have a bubbling effect. And you need to be very careful and control your RPMs and or remove it from its heat source completely because it's going to want to bubble over. Now, there's two methods that you can use to decarboxylate. One of those being something like a Griffin beaker on a scientific hot plate that has a magnetic stir motor, or if you're moving up into scale, then you can use a glass reactor. I would always advocate advocate that whatever decarboxylation you're doing, don't push throughput, especially if you might have some residual solvents in there. You only want to fill your container up to about 2/3 of its capacity. That will allow us, if we approach volatility, we have the ability to mitigate some of those risks. There was actually one instance that I had in a laboratory where I filled that Griffin beaker. This was many years ago, but I still remember it because it was crazy. I filled the Griffin beaker all the way up, began my decarboxylation process. Everything was going according to plan. Everything began to boil over. As it boiled over, I could not catch it fast enough, and these things were at 120 degrees Celsius, so it wasn't like I could just snatch it up off of the hot plate. It boiled up over, cracked the hot plate, burned the filaments, smoke started filling the air, and this was cannabis oil. So now you had cannabis smoke filling our entire extraction and post-production laboratory because I was learning back then to make sure that I managed my volume going into my decarboxylation. Also, I had left a little bit too much solvent in there, so that's where it's really good to make sure that you're getting your solvent recovery adequately. And that is going to be effective decarboxylation. Now, it is also noted that just because your external temperature controller, for instance, your jacketed reactor or whatever is heating that, or in this case, a hot plate stir motor, is saying that it is at 140 degrees Celsius, does not mean that is the internal temperature of the oil that you're decarboxylating. So it's always really good to have one of those laser temperature thermometers on hand. These are pretty cheap. You can get them for around 35 to 40 bucks at any of your local convenient home improvement stores or scientific stores if you wanted to go super fancy, and just make sure that you're taking in almost to the oil. You don't want to dip it in the oil naturally, but you want to get a good reading of the oil. So that might mean that even though your hot plate is at 140, you're not adequately decarboxylating at 140 degrees. So your hot plate may need to overcompensate depending on the type of oil that is in whatever your container that you're using to decarboxylate. The reading might be 150 to 160, so we can get that 140 degrees Celsius for 45 minutes. It's very important to note that that's the temperature of the oil and not the external temperature of the heating unit. Now we're going to get into the distillation phase of our 7 target areas, or 8. We had 8 target areas. We're going to get into the distillation phase. Now there's 2 pieces of equipment that we can use for distillation, and everything is going to be directly attributed to scale and throughput. If we're doing a smaller scale, or we want to be more meticulous about our conversion or anything that we're doing there, and I know that we already said that we're making vapables and dabbables, so for this instance, a short path distillation system might be good for us. I personally like the G33. I like it because of the packable head. I like the ability to be able to put some sort of filtration media inside my distillation head. Here's another misconception. We're doing Mythbusters right here. Here's another misconception, is that the larger your distillation head, the greater your throughput increase. That can be true in some areas. However, I found that a smaller packable head, like something like the G33 that you can get from Lab Society, is going to do the exact same throughput as one of your fancy $17,000 distillation heads that says that it increases the surface oil area and potential coils for doing distillation. Now, once we have that short path distillation unit, then we can adequately go through and control our distillation. And remember, the thing that is going to increase your throughput the most is always going to be the way that you handled your oil before it went into your short path setup, or even your white film setup, which we'll get into in just a minute. Now in our short path distillation setup, we're going to be thinking about 3 fractions. These are going to be, for reference, called the heads, the main body, and the tails fraction. And you're going to be able to see there, we're not necessarily going to train you in this video how to do distillation, but just give you some key tips on how you can build your laboratory and making sure that you've got the perfect solution for monitoring these parameters. Once again, we do not want to be noticing the temperature of our heating element. So for this short path example, what we'd be looking at is a mantle that is encompassing the boiling flask. That's what's going to be delivering our heat. But a lot of times we're going to have a thermometer that's going to come in through a thermocoupler that is going to give us a reading on the oil inside. And that's great. That's fantastic. Do we definitely want that reading? Yes. And it is also directly connected to the mantle in ensuring that we don't overheat and cook our oil. But the most important temperature that we're going to be able to pull on on our short path, and I find a lot of them that are missing them, and I cannot stand these type of short paths, and to be honest, most of them are the cheaply made products, is a vapor temperature thermocoupler, because the most important part, the whole reason that we're doing distillation, which is in fact the art of heating something up to its boiling point and to a gas vapor and then recondensing it back into a liquid to capture it and leave the undesirables behind, is the entire reason that we're doing the distillation process to begin with. That means the most important parameter is going to be our vapor temperature, because based on vapor temperature we can tell not only what fraction that we're in, but also if we have a chart for reference of different cannabinoids that boil off at different temperatures, obviously we would be reaching our delta 9 THC way before we would ever get to THCV, which has a much higher boiling point, right? So we just want to make sure. Now, when you're doing CBD and THC, and I'm just going to go ahead and completely keep busting myths the entire time as long as they keep coming to my head, is if you get sold a piece of distillation equipment and that equipment manufacturer tells you that you will be able to effectively, because the boiling points are different, separate CBD from delta 9 THC, that equipment manufacturer either A, has no idea what they're talking about, which is ignorance, and in this case they're forgivable, or they are lying to you. And in this case, CBD and delta 9 THC are so close to boiling point, especially when you get under vacuum, all of your boiling points begin to decrease. So because they are so close in boiling point, that means that you're not going to be able, no matter how many cold traps or separate condensers that you set up, I've seen it all trying to figure out how to get this to separate out, you're always going to pull your CBD with your THC. That means if you're using this to make CBD oil, but you're already hot in your delta 9 THC, and your equipment manufacturer has said you can buy our short path distillation unit and it is going to separate it, they are unfortunately not telling you the truth, or they do not know what the truth is, which is fine too. So have them send us an email and we'll get them on the right track. Another thing that you can kind of do to be able to make sure that in your distillation setup you know what cannabinoids are boiling out is there's something called a UV depth meter. Now what this does is it shoots light down your Liebig condenser, because due to the density of each one of the cannabinoids, it's going to return a different light spectrum. Now for people that are very technical, which you may be, this is an ethical method for trying to locate what fraction you are into. However, there's not a way to separate the fraction once it happens. So main body is going to be all of your volatiles and terpenes. You don't want those. I know some people that like to reintroduce their terpenes after they've got them from their head's fraction, but anybody that's run a distillation system can tell you that smells like dead fish, and there's no reason why anybody on any recreational market will want to smoke a dead fish vapable pen. So discard those and reintroduce something like our favorites are True Terpenes. They make a lot of natural derived terpene products that you can put in there to make sure you've still got a natural product flavor and taste. Now your tails fraction is going to have the back end of all of your cannabinoids, and it's going to be thick in consistency. So this can be rerun at a later date if you want to. Your main body fraction is going to be what we were talking about, where we want to target 90% total active cannabinoids. Now another good solution for distillation, especially at scale, is going to be your white film distillation setup. I really like these because you don't have to go through a bunch of different fractions, but because there's and we'll have a video for you showing you how all of these products work, but for now just imagine that everything is going to be combed out on a molecular level. So your good stuff will go down a short path to a side that you're going to collect, and your residue will stick to the wall and fall out. That will allow you to catch both separately. We really like the ability to control 3 temperature stages. We want to be able to control our hopper that's going into the wiped film distillation setup. And there are a lot of wiped films out there, and all of them will do basically the same job. Just make sure that we have our 3 different temperature controls. We want to be able to control that hopper. We want to be able to control the molecular head, whatever is using that comb. And then we want to be able to control the cold trap that is going to our vacuum, which everybody should have no matter what. That cold trap is going to help you combat any volatile fumes that might come back into your diaphragm pump. Now for a white film distillation setup, what we need to make sure is that we have 2 separate pumps. For a short path distillation setup, we're able to get by with just a rotary vane pump. However, for a white film distillation setup, we're going to need a rotary vane pump and a roughing pump. Now, there's a bunch of different parameters that people will try to preach to you on what is the proper distillation, something Pascal, negative 25 millibar, whatever you're using to measure vacuum, it's fine. What I always tell my clients is get as deep of a vacuum as possible, whatever you can. Now, due to your elevation, these vacuums are going to differ. If you're higher in elevation, you're going to get a lower vacuum. Towards you're closer to sea level, you'll get a deeper vacuum. If you're all the way in space, you'll get an absolute vacuum. That'll never happen here on Earth, but we need to make sure that we can get a deep of a vacuum as possible instead of trying to spend a bunch of money to get vacuum regulators and make sure that we maintain a certain vacuum throughout the entire process. Get it as deep as you possibly can. So in a white film distillation setup, that means that you're going to need to start out with your rotary vane pump and then supplement that with your roughing pump. Now, there's another part of distillation that we can talk about that may be an ethical solution for you, and I would highly advise against it. And this is the spinning band distillation system, and there's really only one company out there that makes them. And since I'm making this video to give you value and not to bash or disregard other equipment manufacturers, I'm just not going to mention their names. However, if you are considering a spinning band system, I would definitely advocate that you look at the 2 other processes that you can do. You will find that you might encounter some problems. All right, now let's get into filling and terpenes. Now we have our first pass distillate. It's a beautiful distillate. We made sure we got 90% total active cannabinoids. We adhered to every part of the post-production process, made sure that we took good care of our oil all the way going through. We have great infrastructure. Everything is coming out perfectly. Now it's time to fill up our terpenes. Now you can use, like I said, if you wanted to do one of those manual terpene or manual filling carts, you can totally do that. The important parts of the product here is get you something that will maintain a throughput temperature, a good temperature throughout the entire throughput. That means the oil is heated, but also all of the hoses that go down into your needle and everything like that is heated as well. That way things don't start to clog on you, because we all know that distillate, when it's warm, flows freely. When it's cold, it starts to clog up, and this is painful to clean out, especially if you get a clog in the middle of your production day. So there's not really a one-size-fits-all for all of your filling carts. There's many reputable companies out there that make a good filling machine. The most important part that you're going to be thinking about here is to make sure that every part of your system is heated. That means the hopper that is holding all of it, all of the hoses that are going to the needle in and of itself, all of that is heated. The next thing that you want to make sure is when you're using a vape pen, make sure that you get a reputable manufacturer for the cartridges, because you do not want things to expand or explode or leak in someone's pocket or do all of those things as it's, exposed to sunlight or extreme temperatures. Maybe it's a cold winter day. You want something that is going to consistently give you a good, smooth vape every time, all the way through the last vape. Then we talk about terpenes. Now, terpenes you can come by in just about any way, shape, form, or fashion that you can think of. However, if you wanted to take your rotary evaporator, for example, and take some strawberries or some orange peels or some lavender or whatever you wanted to, mix it with ethanol, throw it in your rotary evaporator, rotary evap all of those terpenes down, you could take those terpenes and reintroduce them into your vape pen. So all of your major tastes, smells, all of those flavors are going to come from 7, and there's also alpha and beta of each of these 7, but just kind of like the color wheel that's of 3 primary colors, you have most of your tastes and your smells will derive from those 7 terpenes. That means that in any different combination or formulation that you make, you might get a strawberry banana, you might get a mango citrus, you might get a lavender orange, it just depends on what you're trying to make. Either get with a company that can formulate those recipes for you and are known to put natural, not synthetic terpenes, because if you've gone through the entire process to make sure that you have a great business model and now you're cranking out production and then you just add a bunch of synthetic terpenes to the mix, that is going to be the #1 harsh report that you get back from consumers when they vape your product and they get that cough or that grunt or it burns the back of their throat. It's all probably going to be either A, too much terpenes, or B, not natural terpenes. Now, too much terpenes, we always recommend a 5% terpene ratio, and we'll just leave it there. Whatever a total percentage to the weight of oil. Now, if you wanted a 1% limonene and a 2% pinene and a 3% carophyllene, then that's fine. That would be 6%, or 2% carophyllene, 2% limonene, 1% pinene. Whatever combination that you wanted to make your terpenes is fine, but I recommend that you do not add more than 5% terpenes, because also we do not want to give our consumers a bad taste. Now, the last area of our 8 target areas that we need to consider is safety. Safety. And you need to be adequately trained on safety and how to cohesively go through and make sure that you have an adequate safety plan. Now, if we, for instance, are building you a laboratory or called out to a laboratory to consult for you, if we do not have these 10 things, we will most of the time not even step foot into the laboratory, or we might step in just to tell you that, hey, you've got a checklist to do before you can call us back out to operate, because our number one priority is to make sure that everybody is safe around us. Throughput, everything, clarity is good, but like we said at the beginning of the video, if you're at risk to yourself and or others, there's no point in doing business that way. In this specific product that we're going to be making, we need 10 things. We need to make sure that we have 10 separate areas of safety. Number one is going to be ventilation. That means that everything that you're doing inside of your laboratory when you're using LPG gases, solvents, and all of those things are going to, at some point, release some sort of fumes into the rest of the laboratory. That means we need to have a way to not only be constantly exercising a negative pressure inside of your laboratory, which means air supply is coming in and your ventilation is taking air out, but also in the case of an emergency, be able to keep up with 30 air changes per hour, which means it needs to kick on and make sure that everything is getting evacuated out of that laboratory if it should reach a critical room situation. Next is you need to be trained on what a critical room situation is and how to handle that type of situation. And if you don't, then you need to have an adequate evacuation procedure to make sure that at least your ventilation can take care of all of the dangerous or flammable gases or vapors that are inside of the laboratory while you and your employees all move to a safe location. Number 2 is a fire suppression system. If you detect some sort of smoke or flame inside of your laboratory, you need to have some sort of suppression system, not water, but some sort of gas fire suppression system that will kick on and alleviate those flames and make sure that none of your other pressurized containers explode from being exposed to flame. Number 3 is a static discharge mat. Remember that if you're in a Class 1 Division 1 environment, which we're going to go over in the next step here, if you're in a Class 1 Division 1 environment, that means that all electrical sources and all potential hazards or spark sources have been taken out or alleviated from the room. That means that you yourself are the only potential combustible force, which means that you need to have static discharge mats in place. So when you enter the laboratory, you stand on your static discharge mat that is grounded to a grounding rod for about 30 seconds before you enter the laboratory, and then anytime anyone else goes through there. Also wear non-static conductive material, something like scrubs that you would get at a medical profession or something like that, and just make sure that you're wearing material, not a cotton wool fleece sweater that is going to generate a lot of static electricity. That is going to be an issue. Number 4 is Class 1 Division 1. Class 1 Division 1 is an electrical rating that is going to determine that everything is intrinsically safe as far as it relates to electrical components. That means that everything that can create an arc or a spark or a circuit or anything like that, any type of a piece of equipment or circuit board that has an electrical source is all going to be intrinsically contained in something like silicone, which means that if vapors were to circulate around the laboratory and they were flammable and there were electrical procedures going on inside of the laboratory, that there is no possibility that any of those gases could get into contact with a potential ignition source. That's what Class 1 Division 1 means. People that work in the paint industry, it's very easy to find these. Number 5 is gloves. Many times you're going to be working with either very hot or very cold, but extreme temperatures one way or the other. So it is very important when handling dry ice or any of your freezing columns, anything that you're using like that, to always make sure that you have heat application gloves, cold application gloves, and some nitrile gloves to make sure that you're not getting lipids and oils all over your fingers and then transferring them all over all of your products, especially if you're trying to be in a pharmaceutical nature. So 3 different types of gloves. Number 6 is a lab coat. A lab coat is going to give you the ability to shed your clothing quickly in the case of some sort of spill or contaminant that gets on your skin. Something like a catalyst that you might be using, some sort of acid that you might be using to convert, will allow you to quickly shed the lab coat and get out of the danger zone without taking all of that into your skin. And the skin will absorb just about anything that you can put on it. Number 8 is a gas detection system. This is going to be an LEL meter, and this is going to work cohesively and simultaneously with our ventilation system. As our ventilation is running normally, as it should be, air's coming in, air's getting sucked out constantly throughout the laboratory. When I said that we needed the ability to kick on that fan in an emergency situation, that's when the LEL meter is your friend, because maybe you are not able with your superpower human minds to detect that there is over the explosive limit of gas in the room. Well, the LEL meter will. It will tell you that you're over the explosive limit. It will immediately send a signal to that fan. That fan will kick on at 3 to 4 to 5 times its power and will evacuate as well as sound an alarm to let you know that, hey, you are now maybe possibly potentially in a critical room situation that you need to be aware of. Gas detection is always every closed loop extraction system. A gas detection unit is your best friend. It's like having another person watching your back while you're going through the laboratory. Number 9 is alarms. And so your gas detection system, your alarm, and your ventilation is all going to cohesively work together to make sure that you are notified, even in the process of loud machinery, in the event that you're not paying attention to the amount of gas in the room, but that everything works together as a unit to pull everything out. So alarms are good. Number 10 is going to be cameras. Now, cameras is less about safety as it pertains to you working in the laboratory and having risks associated with equipment, and more of making sure that you can potentially mitigate any risk that you might have from any employee negligence or anything that's happening. It also allows the manager to be able to keep an eye on his employees. There should never be a man or a girl left alone in a laboratory, even if it is a one-man job, because if something happens to them, there's nobody to notify somebody else, and cameras will help you go through that as well. It will also help detect new people that you're bringing in and out of your laboratory. Maybe you're doing a showing. So all of these things are going to work to advocate for the safety of you, yourself, and the security of your laboratory. Now that we've got all of our problems together, solved, figured out, we've got a good pipeline, we need to worry about sales. We need to worry about sales. Now, a lot of people will consider this, and this might also sound counterintuitive because I put it at the back end of the video instead of at the front. But actually, during the processing of everything that you're looking at to make sure that you've got a business model in front of you and you're going to be operating a laboratory that is going to be producing and extracting all of your cannabinoids that you're looking to send to the recreational market, the number one thing is sales. Whenever you get into how do you return revenue back into your pocket after you've made a significant investment. And a lot of people say, well, I'm going to skimp out on this investment now. That way, when I get more investment, I'll scale up. But if you didn't adhere to your sales channel, you're never going to get that investment back, and you're not going to scale up to anything. And it's just going to be a backsliding down this slippery slope that you're going to have a hard time getting a foothold in. So need to make sure that you build that sales channel in the middle of while you're making sure everything will be produced. Don't wait until you start producing to build a sales channel. That means you're going to have a backlog of products and no way to sell them yet. Make sure that the end of your pipeline is open, clear, open light. So the way that you can do that is you can formulate relationships. Make sure that you're formulating relationships in the cannabis and hemp communities, but depending on where you are, that you're making sure that you're going to conferences, cannabis conferences, maybe you've got cutouts, cardboard kiosks, whatever you've got going there, but make sure that you're talking to people. A lot of people in the industry, and I do believe that it's starting to change, have always been shielded. That's why it was very difficult as a new and budding technician to learn all of these things that I'm teaching you. Luckily, we were blessed and we had the ability to learn from somebody else. But even the people that watch a lot of our videos and consult with us, they say, man, we've been looking for this information all over the place. And I'm thinking, well, there's got to be a bunch of people that know this information. But even in the relationships that you build, people are very secretive about what they're doing and how they're doing it. They don't want anybody to excel over them. That is not going to behoove you or give you any type of profit margin when you're moving into this industry. A lot of this industry is going to be built on relationships and the ability to be transparent throughout. And you will find the more transparency, the more that you're willing to share, the more that you're willing to love on people, respect them, and they respect you, is actually the more money that you're going to make. When you're secretive and closed off, people can sense that and they're not as willing to do business with you. Have your product sold before you start producing. This is a big thing. If you can already build a reputable brand awareness, and all of this is happening while you're getting all of your equipment together, then as soon as you start producing, it's already sold. And that means that your investment is going to come back quickly. And number 5 is build integrity. If you say that you're going to do something, do it. If you say that you're going to make something, make it. If you say that you're going to meet a deadline, make that deadline. Keep your word, because when people come back, you might get them for their first type of business. You might trick somebody into buying your first product. However, there's no way that they're going to continue to call you back and buy more product if you do not have integrity. Keep your word, make sure that you fulfill your promises, and this is going to allow people to say, hey, Bob from so-and-so extraction unit, I know that if I give him this contract, he always keeps his word. If he says it, he'll do it, and that's going to bring you more money in the long run. So now, the very last thing that we need to consider is sourcing our biomass material. Now, this is important whenever you begin extraction. And I'm not really going to get into too much of this, but there's 7 things that you need to think about when sourcing your biomass. And the first thing is homogenized testing. Just know that farmers are allowed to take a homogenized test, which means they're going to mix all of their material together, and that is going to allow them to give you product that might be testing at a certain percentage of cannabinoids, even though it is not necessarily all bud material. You go to extract and condense all of those cannabinoids. That means that you're going to find that all of the stuff that was in the homogenized test is now less concentrated or more concentrated as it goes through extraction, and you might not have the results that you're thinking for. So if you don't know what homogenized testing is, it's always good to ask your farmer, is this a homogenized test? Number 2 is a reputable vendor. This goes back to building integrity in your sales channel. It goes back to building integrity anywhere that you are. Make sure that you're using a farmer, and I would highly advise you that just because the price is right and it might be cheap, to not just jump directly on that source of biomass. And I understand in some points of our business, this is some strategies that we have to take, especially if we're having a hard time getting things up and going to begin with. It might be that you need to make, a few adjustments to how much biomass or the quality of biomass that you can buy to make sure that you can at least start producing, but I would always advocate that you use a reputable vendor. Number 3 is moisture control. If you're getting a bunch of biomass and you're leaving it there in your laboratory, you've got to know that biomass's number 1 enemy is going to be something that's called powdery mildew. Powdery mildew is going to happen, or mold is going to happen, when it's just sitting around retaining moisture. So for instance, if you're in a Florida warehouse right now and you're backing up all of your biomass and staging it for your 80,000 pound per day throughput laboratory, and you have no way to mitigate that moisture, you are going to come into problems when you get to extracting. And a lot of people will say, well, if I extract, doesn't that mean that I leave the mold spores behind? And I would say that you are not adhering to the integrity that we talked about just a minute ago. Number 4 is checking the bottom of the bag. When you source the piece of the biomass or the bag of biomass, make sure that you're not just taking out the very first top scoop to look at and inspect. Make sure that you get deep down into the bag and you can see that the entire bag is the same product throughout. Number 5 is the inspection of crystal formulation. This way you do not get surprised when you have suffering yields on the back end of your extraction. The number 1 thing that I like to use for this type of inspection is the jewelry miner. So anything that you're using that you can put up to your eye and you will be able to see diamonds or gemstones, things that you would inspect like that, these work great for crystal formulation. Just know that any of the extraction that you're looking to take out cannabinoids is all in the trichomes. If you are looking at dry water leaves, if you do not have a good crystal content, you can pretty much be sure that when you extract that, you're not going to have a significant yield. Number 6, remember that there are no cannabinoids in dry water leaves. The dry water leaves are simply there to collect water to nurture the rest of the plant. So if you have something that's dark green and trichome deficient, there's not going to be anything there except for chlorophyll that you will pull out and that may contaminate your extract. Number 7 is negotiating contracts, and I love this one. Make sure, if you can, kind of introduce some leverage to your farmer to make sure that you're negotiating a contract. This will hold the farmer accountable, because if you're negotiating a contract, that means that you will be able to return profit on the profit that was made. If the farmer knows that the only money that he's going to get back for his cannabis or his hemp that he just sold you is based on your ability to process it and sell it in a highly productive way, that means he's probably going to try and give you or put his best foot forward to make sure that he's not losing money by giving you that biomass. If you just buy biomass, you're stuck with whatever you've got. So I would highly advise that you source your biomass accordingly and negotiate your contracts. If you're looking at all of these different things and you're like, this is an insane amount of information, how do I take it all in? Just know that you can always go back and replay any of this information. Or if you need a quick one-stop solution for everything that we've just told you and hammer out all of these plans as it is, I highly suggest that you go to seedtoshelf.us and you look at the all-inclusive, because it encapsulates everything that we've been telling you for approximately the last 30 to 45 minutes. Now, at the end, it all boils down to training. You can have the best, all of this equipment set out, and if you do not make sure that you're adequately trained, then you're going to find yourself significantly lacking in your ability to not only handle problems as they present themselves, but to use your equipment as it goes. And this is something that my grandfather told me a long time ago, but he said, buy once, cry once. And it took me a long time to learn that. And after I bought and spent a lot of money that did not necessarily end up to be what I wanted, and I ended up it broke and I had to buy it again, I find that even in a laboratory environment, guys, I've been guilty of it myself, of going super cheap and buying things that break and they cause downtime and all of that. And yes, I saved a little bit of investment up front, but at the back end, I end up spending more money and more headache than it was worth. So make sure that you take all the information in this video. Make sure that if you need a bigger budget to get done what you're looking to get done, then get you a bigger budget. I promise that it will help you in the long run. That is all that we have for you guys today. Thank you so much for tuning in and watching, and we will see you all in the next video.
Seed to shelf. Safe, secure, superior. Seedtoshelf.us.